Intel actually in the 1970s. I haven't worked for them since 1979, so I can't speak for Intel here. I did spend my last sabbatical 7 years ago consulting with Intel. I spent it in Portland, Oregon, working with a group up there, and this work actually came out of that. So it's sort of related research study that we did there, design, I guess. And it's related because, as you may know, when companies have ideas that they think are good ideas and they actually want to put in products, they don't necessarily want you to go publish papers and give talks and tell them how great their ideas are. In fact, they'd rather that nobody ever find out about it. They just like to put it in the product and it's a trade secret and nobody ever hears about it. So I specifically looked at cache coherence protocols, which is the notion that when you have multiple caches, you need to make sure that they all give the same value when you read them. I thought since processors are in different chips, and therefore they have to communicate through pins, and since the pins are outside of the domain of Intel, if I'm working on a cache coherence protocol, it's exposed to the outside world, and therefore this will be public. And I was right, except that they still wanted to wait 5 years before they made it public. So it's only recently that I've actually been able to talk about this. So I'm going to talk about some work that is in their most recent processor, but was actually done in 2001. I was working on a project called Nehalem, and as you know, there's a product out now called Nehalem, which in fact has the technology very close to what we were working on back then. However, Nehalem then meant something very different. First of all, it was a process that was going to be developed and shipped in 2006, which didn't quite make. Secondly, it was not going to be a multiprocessor. It was going to be a single processor on a chip, and it was going to run at 6 to 8 gigahertz. So obviously, they had a major change in course because they gave up on clock speeds and that speed, but they also decided that it made sense to put multiple simple processors on a chip rather than use all the transistors that they could put on a chip to build a single powerful processor. So I have to say that they kind of chickened out in the sense that rather than figuring out how to build faster processors, they said, we don't know how to build faster processors, but we know how to build more of them. Put 4 on the chip, go over the fence and say, it's your problem how to deal with that. And it's a sad state of affairs now because we do have to deal with multiple processors, and the world is going to have to deal with multiple processors. And I was speaking with your department chair this morning, and we both agree that the notion of multiprocessing needs to be much more embedded in the undergraduate curriculum because multiprocessing is here. It requires some fairly serious rethinking about how we think about computers and how we program. So, also I will say that since I don't work for Intel, haven't worked for Intel, I don't even know anything about what they're doing now except what they've made public. So nothing in this talk is confidential. This is work that I did primarily with Herbert Hum, who was an Intel employee and still is. And I've collaborated with him recently, but the two of us primarily worked on the project that I'm going to be describing today. There's a book out that just came out earlier this year called Weaving High-Performance Multiprocessor Fabric. I don't know quite how to parse that, actually. I guess the second part, Architectural Insights into the Intel Quick Path Interconnect, otherwise known as QPI. And this is a very nicely written book, and if you're interested, I recommend that you get it. It's not cheap. It's published by Intel, and as you know, Intel's a profit-making corporation, even on their books. But it's almost everything that I can say about the QPI part comes from this book, which is a very nice reference. But limited, as usual, Intel doesn't tell all just because they have a book on it. So they recently introduced this, and for those of you who are familiar with what hardware looks like in an Intel system, they have something called the frontside bus, which is the connection to memories, to memory, and maybe connecting multiprocessors to memory. They decided that that was simply not adequate